I think there are a lot of analogies in real world as well, similar to S3, right? If you think about how your water system works, or like the electricity comes to your house, if there is good infrastructure, it's invisible because it just works. You don't think about like, oh, how much water is going to be utilized by me this month, and should I be telling the water division beforehand that I need this capacity and so on, right? The infrastructure just works in case you have a few more people in your house.
Hey everyone, and welcome to the SaaS developer community where we discuss technical topics for SaaS developers. And with me today, I have Ram. And as you know him from the community, he's the CEO of Nile and one of the founders of the SaaS developer community. We wanted to discuss serverless. And basically, when we thought what is the best serverless product out there, we both had the exact same answer at the same time. It was so obvious because it's so popular that it led us to think, what are the thing other serverless products? How can they get better? And more important, when and where should SaaS developers use serverless systems? When does it actually make sense? So stay tuned for a deep dive into serverless. Ram, thank you so much for being here with us.
Thanks, Gwen. And yeah, good to be back. I just wanted to add that, obviously serverless is a huge topic. When you talk about promise of serverless in the context of databases and data management, it gets really interesting. We'll definitely spend a lot more time today talking about like what does an ideal serverless experience look like, and the pros and cons of serverless, and in the context of SaaS as well, for that matter. And excited to like give my thoughts on it.
Yeah, exactly. Because when people say serverless, a lot of times they think compute as a service, they think function as a service. But when we think about what is a really good serverless experience, we don't think about Lambda as being an amazing developer experience. It's actually a controversial developer experience. So, Ram, what in your mind is the best?
Basically, I think what the gold standard would be S3, right? It's been there for multiple decades. And I think they built a fantastic system over a long period of time that actually truly achieves the definition of serverless for me. And the reason is being that it's become so easy to use and manage S3 across the globe. And there is a reason for that, being that you don't really think about things like, compute or machines and capacity, and what do you do when you have more sudden spike in demand and so on. And for me, the way I basically summarize serverless S3 is that it just works.
Yeah, so get us into it. What are the aspects of it works that S3 does so well and we kind of, I think everyone aspires to achieve?
Now S3 does get used also significantly for if you think about data lake, even just metadata of everything in your company gets dumped into S3 today, which is obviously because it's cheap storage. But the thing that's very attractive with S3 as an offering for these kind of like large objects or cold storage is that, obviously, apart from just the pricing and it's cheap, is that it is so easy to do it. And that is fundamentally, I think, a key differentiator for S3, that they made it so easy to just dump all your data in and not worry about thinking about what's going to be the capacity next month. Do I need to think about upgrading my machines? Do I need to think about, not utilizing my idle machines because I'm storing the object, but I'm not reading it anymore for whatever reason, right? And these are things that don't exist. They've just been eliminated from the experience standpoint, which makes it really really easy to just dump data into it. And when you make it when you make something so easy, it becomes accessible to all, and then soon enough it becomes kind of the standard um, for all use cases. That's kind of what S3 ended up doing, and I think they did a great job at it.
Yeah, and as you said, you mentioned that you don't have to plan disk space and that you don't have to think, am I using not enough, too much? I just realized, does anyone even monitor S3?
If I was a developer using S3, the part that I would monitor would typically be the availability aspects and less about the storage and compute aspects of like what I'm trying to use and whether I have capacity and whether my service will stop working because of capacity. It'll largely be that, oh, is S3 even available? And if not, what do I do, right? Which is the nice thing with S3 as well is that it's multi-region, which means you can actually build capabilities to switch to another region if you wanted to, and it's eventually consistent. I think very recently, or maybe like a year or two back, they also added strong consistency for some use cases. But yeah, I think it's kind of the holy grail, right? Of
Yeah, totally. I was thinking that it became, because it's so easy to use and so much, I just dump stuff. I don't even have to think about it. I think the last major downtime was like, I don't know, 5, 6 years ago. The entire internet went down, including big parts of Amazon, because everyone counts on S3 to just be there.
yeah, exactly.
Yeah, I
So
think every product should aspire to become critical internet infrastructure.
exactly, and that's a great way to put it. Is that I think now that you remind me, I think there are a lot of analogies in real world as well, similar to S3, right? Like if you think about how your water system works, or like the electricity comes to your house, if there is good infrastructure, it's invisible because it just works. You don't think about like, oh, how much water is going to be utilized by me this month, and should I be telling the water division beforehand that I need this capacity and so on, right? The infrastructure just works in case you have like few more people in your house, and the consumption goes up, but still things work. So I think a good analogy to that is S3 in the infrastructure world is that they have made it to a point where it can be considered as this underlying, highly reliable, and just works kind of an infrastructure that you don't even realize that what a great job they're doing unless they have a failure, um, like once in a blue moon, right? So yeah, I think it's fantastic.
So,
Yeah,
translating it into a word that I think we both know quite well from our experience, let's say that we look at S3 as the ideal. How does it translate to databases? What would the ideal database experience be like?
yeah. I think for the sake of this particular argument or conversation, let's assume that everything is possible from a technical standpoint. So we'll get to that. But it's always good to dream, right? It's great to dream about what the world should look like, and especially databases. And then we can work backwards and figure out like how it needs to be achieved. And I think all great things are essentially done that way. So in the context of databases, I really think if I had to like think about an ideal experience in the database space, uh, in the ideal world would be that a developer creates a database, um, and when they do create the database, that's pretty much where most of their operations end. And what I mean by that is, what's going to happen typically is, let's take a standard developer flow, right? Where they're creating their first app on their laptop, checking in code, pushing it to production, getting users, and then more users come in, and then they deal with performance issues, and they deal with scaling issues, right? Um, and if you just take that cycle, uh, and we just walk through like how does the ideal experience will be in all this particular case, I think from a early experience perspective where I'm just creating my first project, All I want to do is to be able to not even think about any, like I create a database. At that point, I shouldn't be thinking about things like compute, what instance types do you have, or think about like what is this going to cost me if I'm just going to do a few hours of testing and then just go sleep, right? It should just work. And if I come back the next day, open up my laptop and start testing again, it should just work, right? The last thing I want is to say the database is not available, or ask me to wait for 10 minutes to use the database. So ideally, the ideal developer experience on your laptop when you create your first project should be create a database, start pushing, writing and reading data. Uh, let's take example, right? Let's say you are creating a relational database, and you are starting to like write code in your application, your business logic, and you start interacting with it with whatever standard protocol that database supports. Um, and then pretty much it should be it should be basically that's it, right? There should be nothing else you should be thinking about at that point in time except for building your app. So all the aspects of you know the hardware configurations, operations, all of that just don't even exist in that world.
That's a very good point. I mean, when I'm running, let's say, on Postgres and in my own machine, it just like I start a process, I start a container. I obviously don't have to think about much at this point. But if I wanted the same thing run by someone else, it's usually actually higher friction to use a cloud service than to run it locally. So I don't do it. I just run it locally and I don't think about CPU and all that. At some point before it goes to production, that is when I have to start worrying about those things, essentially.
Yeah, so I call this think queries, not compute, right? Which basically means as a developer, I should always be thinking about what queries to write to build my app. And ideally, that is where my role ends. But let's say you are able to find a database that one click, create a database and start pushing queries to it, um, write some tests, and then run it through the night to see how things work. And then you come back in the morning, and you're going to not be surprised about any kind of massive bills because the test ended, which means your database is not charging you anymore. Um, and there is no thought process of, oh, this machine is idle and running at this point, and I need to wake up in the middle of the night to stop it, right? After my test ends. None of that exists. And if you get that experience, that would be my ideal developer experience for databases. Um, but then there is more to it, right? Which is now let's say I have this app that just works on my laptop. I need to like now take it to production. Now things become a little bit more complicated, which is now I'm going to be like obviously not too optimistic that I'm going to have like millions of users overnight, which happens sometimes, but not always. But I need to at least be prepared that, okay, let me get my app to production and maybe tweet about it, and I'll get some users to use my app. And even that simple thing requires me to think about what kind of instances do I need right now in a standard database and not a serverless database. Um, how much capacity do I need? What should I be paying as my fixed cost or a provisioning cost, irrespective of whether I have users or not? And all of this will play into your mind at this point, and you'll have to spend time figuring out, um, what the choices that you have and pick different options within that. And I think again, these are things that are pretty much not necessarily a thing that you should be thinking about when you're launching your first app. The other thing is also is that now you're going to have a developer environment where you're saving cost, which means you're going to have different computes, um, with different hardware configurations and all of that, while your production will be in a very different configuration. And oftentimes they may not even have the same set of like issues reproducing in these two different environments. While if you don't have to think about all of these things. And if the database can promise you the consistent behavior, no matter how many databases you create, then you're going to have a very consistent looking database in your pre-production as well as your production. So that's kind of another benefit of pushing some stuff to production, and not thinking about all the standard database problems that you might have before launching. Um,
Yeah, I think an aspect of it is there's the interface between the hardware choices that someone made, or even the virtual hardware choices someone made, and the way your application uses the product, things that you as a developer actually need to think about. Like, for example, how big should my connection pool be? Well, it depends. How many connections can my database successfully serve? Again, even if you see S3 as an ideal, I don't need to think about these kind of things. It's the database itself has those configurations, and as things scale, as my usage ramps up,
right.
it actually allows more and more connections to show up.
Exactly. Ideally, you want a world where connections are infinite and you don't really think about it. And obviously, there's always going to be some aspects of pricing for the database based on what you use, but that is independent of you having to figure out what should your connection pool size be, and then trying to manage the connection efficiently within your app in terms of making, like, your design itself has to think about all of this, which makes it a little bit more complicated than what it needs to be. So yeah, I think that that's not one such resource that you have to think about again before going to production, and that would be eliminated in an ideal world of a serverless database. So yeah, I think for production world, I would think an experience like where I can just, the way it should work is I have a database, and now I want to push to production, so I create another database which is production. Then I should be able to like replicate the schema, which should be like, as part of just creating the database, I should be able to do that, right? Like it you don't even have to think about how do I take the schema and now apply it to my production database and all of that. um, and ideally this should be like through some um, like change management system and all of that, but again, you still want it to be done in a way that it's seamless for you, even though you get the change management capabilities. And then finally, you essentially start using your app, push your app to production, and the app starts talking to this new database, and that's it, right? It should just work. And if somebody starts using your app, users come onto your app after your tweet, uh, things just work. You have high availability, you have unlimited scaling power, you have the ability to like not pay for anything that if you don't get users, unfortunately. um, so yeah, so I think that would be the ideal experience from a production perspective.
Yeah, something I'm curious about. How do you think about performance in this world? Like some applications are very latency sensitive. Some applications actually it's okay if they're slower. Like my small side hobby. Why does it need to be fast? Um, I'm assuming that like in a serverless world, I could somehow give like maybe targets of how fast or slow it's going to be. On the other hand, like S3 is like one speed fits all. Like this is the speed of S3, take it or leave it kind of thing.
Yeah, I think that is one space where uh, relational transactional databases do have a much more varied kind of use cases. um, Now even in S3 world, you do have the things like multi-part uploads and parallel uploads, as well as like thinking about whether you want to, what size of chunks you want to split them if you have really large blobs that don't fit into a single blob. So there are a lot of knobs that you can have to think about. So I do think to some extent, users should have some level of control over the performance of their query. Now, what I mean by that, again, is there's a line between what they can do at the query level and what they have to do at the hardware level, right? And this is where I think serverless can provide a superior experience. Now, in the ideal world, what you want to do is you type your queries, and something goes wrong in production where you're seeing some high latency. Now you want to be able to figure out who is getting impacted, which set of customers are being impacted by the query in the first case. So you do want to be able to evaluate, is this query impacting all customers or a subset of customers? I then need to understand why is this query behaving the way it's behaving for that specific set of customers by looking at their data set. And then probably try to, you know, analyze the query in that context of that data for those customers to see what is the plan being generated for those queries, um, and kind of optimize, right? Uh, but this is very different from me now thinking about, should I be thinking about what is the memory on my server side? Should I use SSDs or like like standard hard disks? What type of disks should I be using? Is this even a memory problem or a storage problem and whatnot, right? Or is this a network bottleneck? These are things that ideally can be eliminated by the user not thinking about it and the serverless database doing the right thing, while the users focus on the query and the life cycle of the query. And the life cycle of query would be largely understanding which customers are getting impacted by this query, why, being able to analyze that query's plan and being able to optimize that plan, because oftentimes there are certain aspects like creating indexes for example, um, which are in the hands of the users. Now you could kind of push the idealistic database world where the system automatically creates indexes based on query patterns and all of that. But no matter what, there will be some level of manual control that users would like, because guess what, sometimes you just know ahead of time that you need an index, and so you do want to create one. You might be doing it this You might be doing some benchmarking in the testing phase, and you might want to create some indexes to like really understand like what needs to happen. um, so as long as the users are focused on the query and the problem around the query and how they can improve it, and we give them the right knobs to improve the query performance, usually it's going to be to rewrite the query, leverage the right indexes for those queries. um, then that's cool, because then they're focusing on the right problem. You don't want the significant portion of the time being focused on how do I figure out the server configuration for this one specific query, right? And if you, especially in a large company, no developer is going to take one query which is not performing and then go and change a bunch of server configurations for that. uh, because guess what? You have to now think about cost implications to everybody else if you're going to do that, and you might be impacting other queries in a multi-tenant world if you do that. So the ideal world would be that you focus on your query and how the plan should look like and optimize that.
Actually, that brings up a really interesting point for the experience because, as you know, sometimes performance is not the same for all tenants. We have large tenants, we have small tenants, they have different activity. And sometimes the index that improves performance a lot for some customers may not be actually the right thing for everyone, which puts developers in a very hard situation. Is that a place where you think like serverless is can even
Yeah, I
help
mean,
there, or is it unrelated?
well, it could help, in a sense that, to some extent, I feel serverless is the closest word we have to magic.
Yeah.
In terms of what you're promising, right? And so you can be free to like define your world of what that magic looks like. As I said in the beginning, right? It's all a dream of an ideal world of a database. So yeah, I do think you can do that. You could think about, for example, we ourselves have seen how the index not being there for really small data set is actually beneficial and faster in some cases, while index being there for some large workloads makes a big difference, right? So, but unfortunately, tables are going to be leveraged by all your customers,
Yeah.
and they're all going to have different sets of data set and different sizes of the data. And again, sometimes they might even have their own separate databases. So it gets complicated, and they'll have it's a lot of work to like figure out
Yeah.
what's the ideal query that you have
And
to run.
and I think this is still on the developers, right? It's not there's
Yeah,
not a lot of
that's
magic
right.
there.
Yeah. Now, I think a world where you can actually automatically create, uh, like you can create dynamic indexes and route the queries based on which customer is being, um, his which customer is querying the data might be a possible thing, but it's probably too futuristic. But I think from a near term or a decently long term perspective, like maybe like 4 5 years perspective, I do think having the ability to like have a clear boundaries between the user and the database and what the responsibility of a user should be in the cloud world and in a serverless world is I think very essential. And to me, the way I look at it is users should care about queries, and they should care about tables, and they should care about the performance of these queries. But the way they care about the performance is largely focused on how do they rewrite queries, what indexes they can create, and so on, right? But not think about like what should be my server side memory and capacity or server types that I have to use to like make this query performant. And I, in the ideal world, the database just magically works for you, and takes absorbs the impact of these queries. Now, obviously, this would mean that the problem shifts to a little bit to pricing, because what happens is the database will do the right thing for you, but you might still be very expensive from a pricing perspective because the database ended up creating giving you more capacity. So there has to be, and we'll talk a little bit more about that on the in the when you talk about pricing. But I do think striking the right balance between the magic that you deliver and at the same time providing the level of transparency that you need for a customer on the pricing front, I think will be the right balance.
Yes, I completely agree. And I think there's like this is not futuristic. I'm thinking about systems like I don't think they call themselves serverless, but both BigQuery and Snowflake give this experience. And I had cases where on BigQuery, I forgot to create partitions for a very large table. The query ran for the exact same amount of time as when I did have partitions. So I didn't notice anything is wrong. They just scaled up. Obviously, I did notice when I got the bill. But in many ways, being able to send queries and the system just works. I didn't like nobody complained. I didn't complain. It allowed me to to move fast and keep on building my product. So this is very magical.
Yep, yep. Yeah, so that's the performance front, right? And I do think when you go into production and you have ramp up users, um, you're obviously going to think about performance, and the next thing you'll think about is scaling, which is like, oh, I'm going to get this is my current growth, and I'm expecting 10x growth, and what does that mean to my database? And that's another place where I think ideally all you do is just go sleep, and things just work, right? Where you don't have to think about the again the configurations,
Yeah.
what makes it work, and so on. And at the same time, you might want to be able to cap on, say, the max price that you want to pay for your system. Now, you should have those knobs in place if in case you need it, right? Where you want to provide a price cap and all of that. But I do think the ideal world would be effortlessly elastic, right? Is what I call it, which is being able to effortlessly like not even and effortless here is basically don't think, right? And you can scale up or scale down um, based on your your product growth, and product growth is never going to be linear and always up to the right. It's going to be higher some days, it's going to be lower some days, and that's kind of what every growth graph looks like. And I do think a serverless database can actually mimic the the growth of a typical company or product. Uh,
Let's dive a bit more into autoscaling. and in general about how serverless scales, because there's more nuance here than just don't make it too large because I cannot afford more than $N a month, right? There is also things like what is the minimum size, what happens with it scales, all those things kind of matter. So can you walk us a bit through considerations here?
Yeah, see, my take is auto scaling in a true serverless world uh, is completely invisible to the end user. What I mean by that is similar to S3, right? They're probably auto scaling behind the scenes when capacity goes to a specific percentage. But this is not a concept that you introduce to the user because um, it just exists, right? And the user just continues to use it, and they have, if they wanted a limit, the limit will be based on something else like price, right? Or basically usage. Like what I mean by that is you could cap on number of queries, you could cap on number of the total dollars, you could cap on total bytes, right? But but you don't have this thought process around um, uh, like I'm not turning on a feature like auto scale in S3, right? And I don't think an idealistic serverless database will have that. Now, I do think there are nuances to this, and we'll talk about this in the architectural sections. But if you are having your own dedicated database as well, sometimes some companies and some customers prefer, oh, I need my own dedicated database, or I'm okay with like using your database that is a multi-tenant, right? Now, in such cases, there are some nuances to it where the dedicated world, um, like, I do still think whether it's dedicated or not, you can provide the exact same experience, um, and there is a way to do that. But the more important thing is basically that I don't have to worry about auto scaling as a feature. Like it is kind of by default there, but I have the right knobs that are more customer facing that I can control, like price, bytes transferred, queries per second, and not think about uh, from an infrastructure dimension perspective.
You kind of missed the elephant in the room, which for stateful systems, it would be scaling to zero. Do you think that scale to zero is even feasible for databases?
Yeah, so I think, well, it is a nice topic that people debate about. Now, in reality, scale to zero is, I think, very important, but I also think it's a little overhyped than what it needs to be. So, what I mean by that is, scale to zero is really nothing but when you don't have traffic, what happens? Now, this is relatively the way I look at it is when you're in testing phase, or if you have databases for testing purposes, this is pretty common, right? I'm going to test, I'm going to have a spike, I'm going to have nightly test. Now, it is also very test dependent. Like if I create a database as part of the test, and I just run a bunch of tests and then I kill everything down, it doesn't matter. If I'm going to have a long running database that is shared across all my developers and then all the tests run on this database, then I do think, there are going to be phases of periods of time where there's going to be no usage of the database, and you don't really want to have the database go down or end up paying for capacity that you don't really need. Now, I think testing is a great place where it's very relevant. Now, there are also other cases where it's relevant. Now, in the case of, I think, SaaS, in this context of what we're talking about, it is less relevant because of the fact that SaaS applications are pretty much long-standing applications. Now, if you are very very early in your application adoption, that you're going to have like very very few users coming in and going, then that's probably a period of time where you might benefit of not having to being able to scale to zero.
Yeah, or maybe not zero, but there is a topic of minimum size, right? Like I know it was a big deal when Aurora went from minimum of 2 cores to minimum of 1 core or half a core. This
Yeah,
it's
and I think it all boils down to, so the way I look at it is it all boils down to what do I end up paying. So there's something called utilization, right? And again, this boils down to, are you paying for utilization, or are you paying for provision capacity, right? And if you're thinking about ideally serverless database, in an ideal world, it should let you, price you for the utilize.
utilization. Yeah. So if it's pure utilization, then the concept of scale to zero doesn't even exist, right? I mean, I don't care how you scale. If I don't use it, I don't pay.
It does exist. It's just inherently present in the system,
Yeah,
right? Which is that just the fact that you stopped using it means the system scaled to zero. But guess what? It is so seamless that you don't even think about it as a thing, right? And I
exactly.
think that would be a ideal experience. Now, if you don't have that, then what happens is now you're thinking about computes and what your provision. And then when you're essentially trying to scale to zero, what's going to happen is these compute machines that you just provision has to go down. And if you have traffic back again, you need to bring them back, and have this whole cold bootstrap problem, right? And one other problem with this is all your caching and all of that is going to get essentially pretty much lost in that world, where if you bring up another instance, you're going to start from scratch. And there are ways to like save the state and restore it correctly. It's a lot more complicated if you really want to do it. But the more restoration you need to do, the more you're going to have a longer cold start, right? Um, Anyways, I think we're just getting into the details of the technical side. But I do think, in the absence of a serverless experience, the ideal world, what's going to happen is you're going to have problems like, oh, what happens now to my compute and when does it come back? And if my user is trying to use my app right now and suddenly you're going to have like unavailability for 5 minutes, which means the user is going to churn. Typically, in most of apps, right? Like nobody's going to wait for 5 minutes for your action to perform. So these are realistic problems that I think a good serverless implementation can pretty much avoid.
Yeah, and I have to say that this is one place where the difference between systems that are very close to the ideal, like S3, where I don't think I ever had to wait for it to scale, and pretty much anything else is very stark. Like one of the things when I was load testing Apache Kafka, like our nightly tests, we had to load test a specific load. The test was 2 hours. Out of those 2 hours, 40 minutes were waiting for the elastic load balancer, which is not sold as serverless, but it's kind of serverless, to wait for it to scale up to full capacity, because you couldn't just immediately throw the, I don't remember, 110 gigabit nightly load.
I do have to mention that it is actually hard uh, to get something like that working. But I think the experience benefit that you get if you get one of those idealistic serverless database is extremely valuable. And I do think in general, pursuing that is, I think, worth it over a longer period of time.
And AWS has been doing it, like S3 is, I don't know, 15 years by now.
Yeah, yeah. So
Yeah, definitely. Um, do you want to talk about whether serverless is too expensive or perhaps actually cheaper than the alternative?
yeah, see, I think this is a very common misunderstanding that maybe that serverless is a new thing, a new shiny thing, which means it's providing more value, which means it's going to be more priced, right? Because humans are generally um, trained to think about value and price together. And if you talk about all the great experience, then it has to be of higher value, right? Higher price. But in reality, though, that's not the case because uh, the first thing is that because you're paying for pure utilization and not for your provision capacity, it significantly reduces what you end up getting charged for. The second thing is a good serverless implementation can achieve economies of scale far superior than a standard hosted database implementation. And the reason is because you get much better utilization even on the server side. And if you can get much better utilization at economies of scale, you have a much bigger leverage on pricing and cost, which means you can actually bring down the pricing for your customers significantly. So typically, I do think serverless will end up um, being much cheaper. Um, and the benefit of that is you can actually provide more value for the same price. This is like trying to only talk about what the databases today give you. A better world, I think, is think about a database that is serverless, but also adds additional value and still prices it at the same price, right? And that's a pretty big advantage in terms of leveraging such a database, right? A good example would be like, you know, if let's say there's a standard database, but if they can also enable you to like support multi-tenancy for SaaS applications, uh, it's going to be an additional value, right? Or I think you wrote a blog around what are all the things that a database can do, right? And imagine you can provide all of that but at the same price point. So just looking at the price sticker is the wrong way to determine what is cheaper and what is expensive. The better way to look at it is what value you get in totality from that offering, and then making your choice. And I do think it is possible to have really cheap offering. And more than it's cheap, it's more about what value you get for the price you pay, right? And that's kind of how consumers. I mean, you'd have never had an iPhone become so popular if people were only worried about pricing. They were worried about the value they get for the price, right? And it's a great example of how systems can be optimized and how serverless can play a huge role in providing more value for the same price.
So that means that you're going to get the Vision Pro for $4,000.
I haven't seen it yet, so yeah, it's TBD.
Yeah, so I think we talked a lot about magic, but what is actually feasible? Like we live in a world, technology is extremely advanced these days, obviously, but what actually makes these things possible?
Yeah, I think it's worthwhile talking about certain architectural patterns that enable these kind of serverless systems, uh, and they all have pros and cons, and they all have complexities associated with it. But I think it's worthwhile going through them. Like a common pattern is, a database typically, I think it's useful to understand a database, a relational database, an OLTP system before getting into like the architectural patterns. But from an OLTP system perspective, you typically have, queries being executed. You have certain query optimizations happening. You have certain buffers that are allocated for you to like cache certain results of the queries, and even cache the plans of the queries so that you don't really have to like reevaluate it. And then you have essentially the transactional log that you typically write to for every query within a scope of a transaction. And then you have some kind of like a page, a storage engine, let's call it, uh, which basically has your final data, and anything that you write in a transaction log after it's committed gets applied to the storage engine, and the data that when users fetch the queries from are fetched from this data store, right? uh, Now the reason why this is important is because if you have a system that has this compute, the transaction log storage and all of this in place, how do you take this system and now how do you make something like this truly serverless, where you don't really care about capacity? But if you really think about it, the way to do this would be that, oh, let's take a very, very uh, basic implementation of how you do this in a DIY model, right? Which is, I have, let's say you had a bunch of operators in your company who are trying to create the serverless experience for rest of your developers. And the way that would look like is basically they will have a machine, they'll start with one machine, they'll have this database running, this old TP database. It could be Postgres, MySQL, whatever, and then they would essentially hit some capacity, right? And now when they hit some capacity, they have couple of choices. They could basically change the instance type, right? Now there are multiple ways to do this. One option would be that, guess what? You probably have some kind of a gateway that users hit. You create another database with a bigger instance type, and then you kind of route all these requests to this new database, and then you bring down the other one, right? And you can keep doing this. This is kind of the typical vertical scaling model. And if you had to do this, you might end up having challenges around how do you keep your availability intact when you do this. How do you manage timeouts, and are there's going to be a lot more downtime when you kind of flip the switch? How do you get all the data replicated over to make sure that you're doing a clean cut? There's lots of complications to that. But in fact, what I'm talking about here, even though it sounds complicated, is kind of the very basic, simple step to vertically scale. If you had an operator in your company, right? Now, you can go one step further and do something like provision some more, like instead of one database, you probably have like a few more databases pre-provisioned for you as in the company. And you have some kind of a gateway. The requests hit across all these databases, and you figure out some kind of like very basic sharding mechanism.
Yeah, we're basically describing the sharding model of scale out,
Right,
which is
right.
something that people, I think, on the channel talked about.
Quite a few companies, all the way from
Airtable, I think, showed up and
yeah, I mean,
discussed.
Sigma, Notion, I mean, you name
Yeah,
them, they all end up doing a
yeah,
variation of this, right? But this is kind of the in-house way to do this, right? Which is you kind of pre-provision a bunch of databases. You figure out a way to shard. Typically, what's going to happen in the world of, let's say, SaaS. This is going to be based on customers, right? And you're going to have to pick a database based on a customer, put all the data into that database. So this gives you some time. And then if you wanted to expand, uh, you just add more databases, or kind of vertically scale them. So you have again those two options at every point in time when you scale, where you can vertically scale the existing instances. Uh, Now, the thing to remember here is what I'm talking about here are extremely manual, right? And you probably have to build a significant amount of infrastructure to automate all this. And don't forget that to be able to do all of this correctly, you also need to think about things like how does backups work across all these databases? Um, how does distributed transactions work if you wanted any kind of transactions?
most places give it up, right? I mean, if you look
Yeah,
at
most places
how
that's the
just
default, right?
yeah,
You
I
have
guess we don't have transactions now. We'll be okay.
yeah. So you just do the application level thing to figure out what to do. And also the other thing is you have some kind of shared data that you might want in every database. So now how do you do that as well? Where
And
every
this is
day,
something that people here brought up several times, that there's always this one thing that they cannot shard, and this becomes their main bottleneck.
yeah, correct. And so usually those are the challenges that you end up facing. But as I told you, so there's the vertical scaling aspect, there is the horizontal sharding aspect, and there's the third approach is the decoupling approach, right? Which is um, now these are not mutually exclusive. You can mix and match them, but the third approach is kind of decoupling, where you take the compute portion of the OLTP that I talked about and have them run separately. And you can take the storage part, which includes the transaction log and the page server, and have them run separately. And the benefit of that is usually in an OLTP system, uh, the reason to scale most of the time is going to be compute driven
Yes.
and less about storage.
Yes.
Now, this is not entirely true. There are some nuances to it because you can do some push downs where some aspects of compute do end up getting executed at the storage level. And sometimes just fetching data is enough compute if you have enough traffic to tip over. But before we even get into those details, let's take the simplest problem where the compute layer is decoupled. Then you can instantaneously scale the compute layer because it's stateless. And then the storage layer, um, pretty much can sustain for a much longer period of time without having
You're
to.
talking about scale the compute layer up or even out?
Yeah, so scaling up is a lot simpler. Now, because it's stateless, it's a lot more simpler. Now, if you do end up having bottlenecks, even from a scale up perspective for a compute layer, then you can scale horizontally, but there is a lot more complications to it because things like, as I spoke about, like the caching tier, like where do you cache the result set? Where do you cache all the query results or query plans? And you need to have a way to like share them across the compute layers.
Yeah.
Um,
And
and
and locking of rows if you're into doing
yeah,
that.
so locking could be. I mean, there are certain aspects of this where you could push down
Yeah,
and
true,
make them available across the other computes.
true. Yeah. I'm just
But
thinking that the moment you have a kind of storage cluster and you also scale up compute, you are now in a world where you basically are running two distributed systems. So
yeah,
this is something that, I mean, as a cloud provider, you can probably do, or like as a vendor, but you wouldn't run it in
totally not. And
yourself.
one other thing is this cannot be done with standard off-the-shelf database, right? Like it's not like something that you can just pick and say, "Oh, it's compute, go here." It's not like these are separate, clean, it's not like the database providers, or rather the database builders, like let's say MySQL, Postgres, and other systems, make it easy to do.
Yeah,
So
I mean, technically, you could buy, Oracle Exadata, and they have the storage cluster and they have the compute cluster. It's still not exactly fun to operate.
yeah, I'm again, those are commercial
Yeah,
solutions.
it's expensive.
While if you take the open source solutions,
Yeah,
it's not going to be easy. So this may not even be an option on the table for if you're trying to do this internally in your company.
yeah,
The realistic approach would be scale up or horizontally shard.
yeah,
This is kind of what most people do. But from a vendor perspective, who's running the system for you, they have a lot of potential to actually go and change the core of the engine and the database. Now, the downside to this is that you're changing a database and you're changing core parts of it, and you need to figure out like how long it would take to like stabilize and make the database actually work the way it promises to. um, Now there is a whole aspect of multi-region that makes all of this even more complicated, um, in terms of like how do you actually have you know a database that spans across regions, and how do you make that serverless is even more complicated. But the reason why I bring this up is we don't want to get into the details of how that's achieved, but the thing is how do you, because we talk about storage and compute decoupling, like if you have like transactions, coming back to that point, like how do you do transactions across multiple such machines if you're sharding? But even if you didn't shard, and if it, let's say you did the decoupling part, now if you did have the database span across regions, then you inherently have multiple computes,
yeah.
and which means how do you replicate storage and make sure that it's local all the time? How do you do transactions across these storage systems? It just gets complicated. Um, and also, I do think there is the aspect of performance implications to all of these architectural models. I do think theoretically, um, because there are a lot of optimizations you can do. But the decoupling approach can further be decoupled, where the storage can be further decoupled into its own transaction services and uh, like key value store services and so on. But you're going to end up with a lot of hops, right? In terms of just executing queries, and it needs to be seen like what queries it performs really well and what queries it does not.
I was thinking you're talking about further decoupling in like, let's decouple the write ahead log the way, because
Yeah, that's
we
what I said.
know that Kafka is pretty awesome.
Exactly. That's what I said. So when I say further decoupling, like I was talking about the transaction log being its own service, and the key value store, like the actual storage data core, the storage engine being its own key value store, and so on, right? And you can do even further.
Mm,
You can do even further decoupling, right? You can have its own caching tier, right? That
yeah.
basically a centralized caching across all the services.
Ooh,
Now,
the disaggregated database.
yeah, the disaggregated database model. Now, there are pros and cons to that model as well. The pros is that you can independently scale all of this pretty much. You almost get to this idealistic world of effortlessly scaling each layer separately. Now, the downside to this is one aspect could be performance because of the fact that you essentially have to like go hit multiple such machines for every single query that it needs to be executed. The second thing would be cost, which is if you this cannot be a realistic architecture inside your company. A hosted vendor can probably get economies of scale to have better utilization of all these different layers, while in a company where you just need one single database, you may not really hit economies of scale for any of these individual components. And finally, the challenges would be like operational challenges. It could be a nightmare to manage all these different systems and make them all work. And even think about like the how do you trace an entire query through this entire system, right? Um, could be challenging. So they have pros and cons. I do think it all really depends on the use cases and what you're going after from a serverless database perspective. I wanted to also highlight that there is a one other the gateway that we talked about in the sharding model can be pretty dumb or can be highly intelligent. And the system that you define and build based on these two options can be very different. So what I mean by that is a typical sharding could be like n different databases, and the gateway all it does is let's say shard by customer. You probably have a metadata database that basically tells you which database does this customer reside. A query comes in, and somebody has to basically say that this particular query is for this customer, right? In some form. And then you can basically go look at the metadata layer and query that specific database. And these are all not part of the database. Remember, these are things that you have to build on the side to do the right routing. Now, you could build a system where if the gateway was dumb, all this routing and everything is an application level logic that you'll have to do. And if the gateway was smart, it can do seamless routing of queries, right? Based on looking at the queries and routing them, which requires pretty much, being able to like parse the query and look through like where the query is supposed to hit. Um, Now, again, in a typical, if you had a system that does all this out of the box, then the experience would be fantastic and there'll literally be no extra work. But if not, you have significant operational work, not just at the database level, which is just sharding and data balancing and all of that, but even figuring out how to like what SDKs do your apps use? How do they even write to the right customer? You probably need another wrapper that does the routing and speaks to the right database with the right connection pool. The client side architecture is also pretty complicated than just the server side.
So
Um,
we are getting back to a control plane, I think. Let me explain. You know how when people start talking about Envoy and Istio, and a lot of what is said is that an application figuring out the routing, and it's all on the application logic. Every app has to figure out which app has to talk to. And then they talked about, well, but this gateway can only also service not just discovery, it can also service for observability. It can give a lot of information about latency and who talks to whom, and it can allow you to have some rules around who is not allowed to talk and how a throttling can happen there. And suddenly you see more and more capabilities added onto a gateway, right? And you're describing the same thing but for a database,
yeah,
essentially.
exactly. It's service discovery kind of a thing, but this is kind of like customer discovery, if I had to, for lack of
Yeah.
a better word. But how do you discover where the customer is and route it there? Is also a challenging client side problem. But ideally, you want all of this to be something that you don't even have to think about. Um, Anyways, I think it also gets complicated when the customers and your users are going to be in multiple regions for compliance perspective or latency perspective. If you want to push the customer on the edge, all of these things become even more complicated because now it is not just about routing between n databases within a single region. It's about figuring out globally where to find a customer. So I do think most SaaS companies end up with these problems where even in the day one or day two, they might end up having to serve customers which have high compliance requirements, or they might have simple reason that they're serving to, let's say, EU, and they need the data to be in EU, right? Region versus like the US, um, and these are challenging aspects of
Yeah.
figuring out
So
database
you,
management.
so we talked about some patterns, and then we started talking about multi-region. And I think multi-region is kind of like it almost has its own patterns, like and solutions. Is there some like few approaches that you see people take to multi-region as separate from
Yeah, so
the other considerations?
see, when people say multi-region, it's kind of an overloaded term, and there are two definitions for it. Now, one approach and one common definition is I need my data in another region for failover, right, or disaster recovery, and that is also called as multi-region. Now, in this context of what we are talking about, multi-region is really about different customers wanting their data in different regions and different places in the world, and how do you manage that, right? And a common way to do this, there's another way to do this, which is you basically um, create a completely separate database, right, in another region or different locations.
Yes, that's very common. And then you use the same routing layer to try to route stuff.
Or not even do that. You could probably like have a completely separate compute layer in that region, and the request for this customer goes to that particular region, right, from the browser, and it uses that database. Um, Now, there is obviously another level to this where it doesn't make sense for a compute in US to route to EU data layer because kind of the cost aspects and latency aspects. So usually you want to make the routing decision at the browser or DNS level to like figure out like where to go. But even that, even let's say you figure all that part out, now even if you had a serverless experience in one region, it is not truly still serverless when you're going to have multiple such serverless databases, because now you're going to have to manage multiple such databases, which means, let's say you make a schema change. Now, what does that mean for all these different databases in different places, right? Or let's say you want to do some testing or you want to do some rollouts. How do you do these rollouts to all these different regions, and how do you even figure out like uh, if everything is healthy across the board? So more challenges come into play in the multi-region world, but in the SaaS world, in coming back to that, it's very common to have, it's not about just scaling. It's also about, say, latency, compliance, security reasons where people want their data in a specific place. And I think the way I look at the world is that it's only going to get more regulated and not less regulated. So, given that regulations are going up, I think the challenges of how you manage data manually across multiple locations, uh, I think also contributes to what I think is a serverless experience, because serverless truly means that I don't have to care about the server side, in my opinion. And where this breaks, even if you had a serverless experience, is when you start thinking about how do I manage my databases across all these different systems? How do I even do a very simple schema role? Like if you're making a schema change, you expect the database to just take the change and do the right thing. You don't expect to like figure out how do I make it, how do I make the change across n different systems, and you're coming again back into wearing the operator hat, right? And being able to eliminate operations, right, and keep it to only the queries and not the database side, like the server side, I think will be the ideal final aspiration of any serverless system.
Absolutely. This is, I think we will put it as the top of the description. It's queries and not servers, right?
Yeah, I think queries. Uh, but yeah, I think to finally wrap it up, I do think, given we are a SaaS developer community, I did want to mention that there might be questions around what does serverless bring to the table for SaaS, right? And I want to reiterate that serverless is not about just auto scaling and then scaling to zero, right? It is about the experience of being able to use a database and not think about queries and not compute, which means not think about capacity, not think about um, uh, scaling, not think about um, the ability to uh, think about instance types and so on. It is also about um, making sure that you can seamlessly scale in the future um, without worrying about your customers' downtime and having to even think about capacity planning. Uh, and it also is about uh, all your testing phases, which every SaaS company has to test, and how do you think about the economy or economics of your developer cost and testing cost and margins associated with that, and how scaling to zero or being able to pay only for utilization makes a pretty big deal. And finally, I do think serverless will overall eventually bring down the total cost of serving and adding more value to your SaaS applications, right? So in totality, I do think this will essentially lead to building more world-class SaaS products and SaaS companies.
Ram, this was super helpful and very valuable for every SaaS developer who is looking to the future in this very active space. Thank you so much for joining us.
Yeah, thanks a lot. It was great chatting about serverless. I think there's lots more in this space on the compute side as well, and how they interact with a serverless database. Versal is a great example. Um, Netlify is a great example where they're really going after Cloudflare. And then how do a serverless ideal database can enable a much better overall serverless ecosystem is also very interesting. But yeah, I think it was great chatting. Hopefully, it's helpful for the viewers.